Okay, we can do one sample set analysis using Minitab in two different ways depending on the type of data we have. We may have all the measurements of the sample, like for example if our sample is of size, let's say 30, means that we have 30 observations in one sample and we have all the measurements. We enter those measurements here in the column and then we perform one sample Z analysis on it. Okay, and the second is if we have the summary of the data. We do not have the whole data set, but we have a summary of the data. By summary we mean that we have its mean and standard deviation. So if we have only mean and standard deviation and the means the confidence level, then we can use Minitab to perform one sample analysis also. So in order to do that, we have to go to statistic. We can go from here to one sample inference to Z or T, means if we are doing Z analysis we select this option, or if we are doing T we can use this one. So we are currently interested in one sample Z analysis, so we will select this. So we can go from the statistic menu here to one sample and to Z, okay, this, or we can go from here also. Okay, so we have to select the method from here. If we have the sample data in a column, like all the measurements we have entered in the column here, and then we select that column will appear here, and then by selecting that column we press this arrow, it will be entered for the calculations. Or if we have the summarized data, then we'll use this, and then we need sample size, we need mean, and we need standard deviation. Okay, and then we need the null hypothesis here, and from option we can go and select what type of alternative hypothesis we want to have. Okay, and what is the confidence level we have. Okay, I have chosen one example from your test 2, which is this one. This example says that the response time of a distributed computer system is an important quality characteristic, and the system manager who wants to know whether the mean response time to a specific command exceeds 75 milliseconds. Okay, from the previous experience he knows that the standard deviation is 8 milliseconds, and he executes the command 25 times, means that the sample size is 25, and calculates the average, which is 79.25. This is the sample average. Okay, because it is made this average is calculated from the 25 times the command was executed. So every time they measured the time and then calculated the average for that time. So it came out to be 79.25 milliseconds, and we have to do the test considering the type 1 error to be 0.05. so this is the error, alpha is equal to 0.5. it means that our confidence level should be 95, because 1 minus alpha times 100%, right? So 1 minus alpha times 100% will be equal to 95%. so from here, from this statement, we have this data that our null hypothesis will be 75 milliseconds, and our alternative hypothesis is this one, exceeds 75 milliseconds. Okay, so this one shows that the mu or average is larger than 75 milliseconds. This is the alternative hypothesis. Okay, this is what the manager wants to test. Okay, and from his previous knowledge he knows that the standard deviation is 8 milliseconds. Okay, so this is standard deviation. Then in order to test his hypothesis, he executes the command 25 times, means the sample size is 25. Okay, and then he finds out that the average of the sample size, average time from the sample is 79.25 milliseconds. This is the sample average. Okay, so it is 79.25 milliseconds. Okay, we have to calculate, or we have to test this hypothesis at a type 1 error of 0.05 or confidence interval of 95. Now we have this data Actually we have the data summary. We do not have the data. The full data will be, if we had that, it would have been 25 measurements of the execution time. Okay, and after getting all that data, our mean of those measurements should have been equal to 79.25. so in this example we do not have data, but we have the summary of the data. That is why here we will use this method, summarized data. So sample size is 25 and sample mean, this is the mean, this is not the sample mean, this one is the sample mean. Okay, so 79.25, so we write 75.25, and the known standard deviation, this one is 8 milliseconds. Okay, it will be 8 milliseconds. Now we want to perform hypothesis test with one sample set. So the hypothesized mean is this one, 75, because he wants to know if the execution time exceeds 75 milliseconds. So this is the hypothesized mean. Now in the options we have to select alternative hypothesis. So this is the alternative hypothesis because the manager wants to check if the mean or the execution time exceeds the hypothesized value. Hypothesized value is given here, 75 milliseconds, right? So confidence level we have to select as 95 because alpha is 0.05, and the confidence level will be equal to 1 minus alpha times 100%, right? That is 95%. Now simply we after entering all this, we just press OK. Here is the statistic, so you get all the information. Okay, so this is the hypothesis test. This was the hypothesis that we wanted to test. It has calculated the value z is equal to 0.266. This is exactly the same value that you calculated and yourself from the table, you found out from the table, and this is the p value that you get. Now this is the z test. It has given you all the information. If you do not understand this thing, how to interpret it, it is very easy. You can simply go to help and it will tell you everything about the results, what each of the result mean. Okay, so if you want to interpret those, you can get help from here. Means what this thing means and what this thing means. Okay, so you can directly get help from here. It is very easy to understand. Okay, so actually the understanding is just the same, exactly the same that you have studied in your class, but if you want to seek specific help from Minitab, you can go here. Okay.